Hi everyone, my name is Nellie Gustafsson and I'm a product manager leading the Synapse data science experiences in Microsoft Fabric. Today, I'm very excited to share an overview and a roadmap of the new Synapse data science capabilities we are releasing. First, we're going to go through a key end-to-end data science scenario we are enabling. We will then deep dive into a selected set of tools and experiences we're providing to help users as they go through the data science process. And finally, we're going to go through the roadmap and some exciting upcoming features. You may have already heard about Microsoft Fabric, but let's do a quick recap about the announcement today. Fabric is Microsoft's new data platform for all analytic workloads, and it integrates Power BI, Data Factory, and the next generation of Synapse with easy-to-use experiences for a variety of roles. This brings together the different data and analytics experiences all the way from ingestion to insight. And as I mentioned, this session is going to focus on data science in Microsoft Fabric. Let's start with some key reasons why data science integrated in the analytics platform is so valuable. Analytics is a team sport. A typical scenario involves many different roles and many handoffs. Data science plays a key role in the analytics workflow because it helps us to enrich data for the purpose of making decisions and getting insights. There are many advantages in removing the silos and inviting data science practitioners into a data and analytics platform like Fabric. Fabric is data-centric. Data is at the heart of data science. As you manage your data assets in Microsoft Fabric, you build everything from data pipelines to lakehouses and your Power BI reports. You should give your data science teams the opportunity to also work seamlessly on top of the same secured and governed data. The open Delta Lake format gives you the reproducibility that you need for machine learning, and the native integration with the data infrastructure, like the data pipelines, allows you to embed your machine learning activities nicely into your analytics workflows. Microsoft Fabric is also developer-friendly. Our goal is to give developers great getting started experiences. And with delightful code authoring experiences in the notebooks, with integration with popular tools like VS Code, developers can build out solutions wherever they feel most productive. We also offer rich and scalable machine learning. With a built-in MLflow model and experiment tracking, we allow you to version and manage machine learning artifacts using standard MLflow APIs. With MLflow autologging, we make it really easy for users to automatically track key parameters and metrics during the model training. And we also developed a large set of built-in scalable machine learning tools with our Synapse ML library that you can use out of the box. And thanks to sharing the same fabric as Power BI, we make it very easy for you to embed machine learning insights directly into your Power BI reports. Microsoft Fabric also promotes collaboration. By creating an easy-to-use unified platform for all analytics roles, including data scientists, users in different roles on your team can now collaborate on the same platform, using the same set of tools and integrations. So whether they're working on data engineering or data science or BI, you can now make your analytics tasks easier. This also makes it easier to secure and share data. For example, you can share code, models, and experiments across the team. It simply makes your teams more productive. Now, let's dive into specific capabilities across the data science lifecycle. We're going to start with the data science workflow. This is a workflow I'm sure many of you have seen before in some form, and we're going to focus on a key scenario that helps accelerate your business insights with help from data science and machine learning tools. And when we cover the individual features and experiences later on, you'll hopefully get a good understanding of where they fit in. Any data science process typically starts with formulating a problem, a question to answer. In Fabric, we're making it very easy for data science users, data analysts, and business users to collaborate over the same source of truth. This gives a shared understanding of the data and the problem at hand. For this, we're introducing some exciting new capabilities we call Semantic Link, and we will talk about this a little bit later in the session. Next, your data science teams will need to further pre-process the data that data engineers have landed in lakehouses. From notebooks, code is written to do this pre-processing. But a big part of pre-processing data is to first explore the data, understand it, detect issues, and then address those issues. We are bringing in tools like Data Wrangler to help boost the productivity of users during the data cleansing and preparation phase. And once the data is clean, you want to construct machine learning features and train your machine learning models. With MLflow, we're making it very easy for you to track and manage these machine learning experiments and models. In fact, machine learning items are first-class citizens in Microsoft Fabric. It means that you can control permissions on a model, you can share it, you can label it, you can endorse it. And with our scalable, rich machine learning library on Spark, Synapse ML, you can perform these steps at any scale. To enrich the new data coming into your lakehouses, we offer you scalable batch prediction capabilities so that you can get your insights faster. And with the new Power BI Direct Lake mode, your enriched data is immediately available and continuously refreshed for reporting without any extra steps. Now, let's dive into some of the specific experiences and features that we're releasing. Data Wrangler is a tool designed to help simplify data prep and cleansing while still taking advantage of the power of code and reproducibility of Python. It features dynamic data displays and built-in statistics and chart rendering capabilities. And it gives you the ability to get started processing data frames in just a few clicks. Data Wrangler is designed for a range of experience levels, from newer developers to more experienced developers. And in the future, the tool will support Spark data frames and offer natural language processing to code functionality using Azure OpenAI. As part of the Synapse experiences on Microsoft Fabric, we are also bringing you built-in model and experiment tracking with MLflow. This allows users to easily track and compare different experiment runs and model versions. And with auto-logging, we're also making it very seamless to capture key metrics automatically as you're authoring code to train models. The MLflow tracking support in Microsoft Fabric is powered by Azure Machine Learning, which opens up exciting integrated experiences in the future. With our scalable predict function on Spark for batch scoring, we help simplify operationalization of models. You run your scoring jobs from the secure confines of your data platform without moving any data. Just write the enriched data to your lakehouse and seamlessly serve to Power BI reports with Direct Lake mode. We want to make it easy for everyone to leverage our tools. That's why we've added an easy-to-use guided experience that helps you enrich your data. Simply select your source of data, map it to the inputs of your model, and choose an output destination. And from there, we'll handle the rest and even generate code for you. In addition to features mentioned so far, we also offer you support for the richest machine learning library for distributed ML on Spark. With the Synapse ML library, which is an open source machine learning library that we maintain, you get access to a lot of machine learning tools and easy-to-use APIs for applying machine learning and enriching your data in an easy way. There's a ton of great features in this library, and I don't have time to cover everything, but let's highlight some of the core capabilities. Synapse ML offers training of distributed machine learning models with performant and popular algorithms. We've also added full MLflow support for Synapse ML models. Spark operators in Synapse ML also help you to work with pre-trained AI models from Azure Cognitive Services. And of course, new APIs allow you to apply large language models and those type of transformations directly on your Spark data frames. You can go to aka.ms/spark to learn more about Synapse ML. Lastly, before we dive into a demo, I want to highlight that the Synapse experiences in Microsoft Fabric also come with R language support. Built-in R support for Spark R, Sparkly R make it easy for data scientists to develop machine learning models using familiar interfaces with R. R can be used both from notebooks and Spark job definitions. Now, let's dive into a demo showing you the end-to-end data science scenario we covered a while ago and how it can be implemented in Microsoft Fabric. We are going to look at one of the key end-to-end data science scenarios in Microsoft Fabric. Here, I'm in my workspace and I've created a notebook. Here, we are building machine learning models on Spark for predicting taxi trip durations. And we will then seamlessly serve predictions for consumption from BI reports without any data movement or extra steps. With our notebook experiences, data scientists can quickly get started solving problems using machine learning tools. The raw taxi trip data that we're going to use is in our lakehouse and contains 34 million records. This data contains details about taxi trips, and we are interested in being able to predict the duration of a trip given a set of known factors. This could help us plan and optimize trips better. We are going to take a sample of this data and do exploratory data analysis using Python and popular visualization libraries. For example, we can learn more about our data by looking at the distribution of the trip durations. We can analyze this by passenger count and look at the distribution of passenger counts per trip. In this way, we can detect relationships and correlations in our dataset. We can analyze peak hours during a day and peak days of the week. This also helps us detect outliers and missing values to filter out. And once we are done cleaning up the dataset, we can save the prepared dataset back to the lakehouse. Microsoft Fabric also has a built-in MLflow endpoint. This means that you can easily track and manage your machine learning models and experiments with standard MLflow APIs. We are going to read the cleansed and transformed dataset from a delta table in the lakehouse. After some feature engineering and defining hyperparameters, we are ready to train a machine learning model. Here, we are also starting an MLflow run to make sure we capture and track this iteration. We are using Synapse ML and a light GBM regressor to train this model. And finally, we can log the model version. This process will be repeated for another run with a tuned set of hyperparameters. The model and experiment now exist in our workspace as items. If we open the experiment item, we can see the runs that we just created. We can see all the associated files and details about our runs. For example, we can see model signature and environments. It is also possible to save models from runs in this experience. We can also filter runs in a list and compare different runs and customize charts. This makes it easier to evaluate different runs. Similarly, we can take a look at the model item in our workspace. Here, we see two versions of models logged from our notebook. We can see how we can apply models through various experiences and even copy the code for using a model in a notebook. Here in the notebook, we can run model scoring and save the predicted values in a lakehouse table. With the Power BI Direct Lake mode, this table with predicted values automatically becomes part of an auto-generated Power BI dataset. Thanks to this tight integration between Power BI and lakehouses, data science users in Fabric can now easily collaborate and continuously share results and data from the data science process with stakeholders like analysts and business users. The lakehouse is not only a place to store batch predicted values in this case, but it's also a bridge that helps collaboration. Without any data loading, data movement, or manual steps, this enriched data is now seamlessly served into Power BI reports. And if we want to automate this by scheduling Spark jobs or notebooks to run on a regular basis, it automatically refreshes the Power BI reports as well. The consumers of the reports can now get the latest enriched data to analyze with zero lead time. You have now seen a key end-to-end scenario that you will be able to enable with data science experiences in Microsoft Fabric. But that's not all. We have a large set of experiences and capabilities planned on our roadmap, and I want to share them with you. Semantic Link is a feature we are introducing for a tighter integration between data science and BI. This will help collaboration with stakeholders throughout the data science lifecycle. For data discovery and pre-processing, we're adding support for Spark data frames in Data Wrangler. When it comes to modeling and experimentation, we want to expand our MLflow support, bring you richer support for hyperparameter tuning, and we will bring you AutoML with Flamel. We're also adding support for consuming pre-trained AI models from cognitive services. There's a lot we want to do when it comes to operationalization of models when you work inside of Fabric. CI/CD support and SDK will help programmatic automation. Model endpoints will help you invoke models from other Fabric experiences, like for example, data flows. And throughout this entire process, you'll be able to leverage productivity boosting experiences powered by CoPilots and Azure OpenAI. We don't have time to cover all of these roadmap items in depth, but there are a few I wanted to specifically highlight. Let's start with Semantic Link. One new capability in Microsoft Fabric we're really excited about is Semantic Link, which offers a powerful toolset to bridge data science and BI. But what does this mean? In the next demo, we will look at how Semantic Links helps to ease the collaboration between a data analyst using tools like Power BI and a data scientist using tools like Python and Spark. With Semantic Link, you will see how notebook users can explore Power BI datasets from Python and Spark SQL. This includes things like tables, calculated columns, but also access to measures. Users can explore, query, and validate the data in Power BI directly from notebooks. Now, let's take a look at Semantic Link in action. A data analyst has collected sales data in Power BI and built out some reports for the business. She realizes that she could use better revenue forecasting data and wants to collaborate with a data scientist. Thanks to Semantic Link, data scientists can now tap into the Power BI semantic data model and business logic, and leverage that to quickly get a better understanding of the data in order to answer business questions and solve problems using machine learning tools. Semantic Link offers a Python library called SemPy that helps data scientists and other Python users to access, explore, and validate the Power BI semantic data layer. This layer contains things like tables and applied calculations and logic like calculated columns and measures. With SemPy, all of this can be accessed using tools that data scientists are familiar with, like Python. In this notebook, we're using Semantic Link and SemPy to browse a given Power BI dataset. But first, we can list the datasets we have access to. We can pick one from the list and start querying the data. As we're reading and querying the data, we're working on a snapshot of the dataset, and the results get saved in a semantically aware pandas data frame. We can visualize the relationships between the tables right here from a notebook cell. We can also list available measures in the dataset. For each measure, you can see details like measure names, measure expressions, and data types. This is a great way for data scientists to read these values, but also to understand the logic and formulas behind these measures. SemPy also allows us to read the content in tables and the measure values using built-in APIs. But there is more. Semantic Link also lets you query the Power BI dataset, including measures, with Spark SQL directly from notebooks. Now that a data scientist can easily query and explore the semantic layer from a data frame, it also means that it's much easier to use Python libraries to explore the data. To build a forecasting model, we're going to use Prophet, a popular time series forecasting library. This allows us to build a machine learning model to forecast future revenue. And the training data comes from the Power BI dataset. The forecasted values are written to a delta table in the lakehouse. And thanks to the Direct Lake mode, we can now seamlessly make them available for Power BI reporting. With Semantic Link in Microsoft Fabric, we are really excited to bridge data science and BI. To empower all users with AI, Cognitive Services pre-built AI models will be integrated into Microsoft Fabric. Users will be able to access text analytics, anomaly detection, text translator, and other AI models out of the box without the need to pre-provision any resource in Azure. But it doesn't stop there. We're also adding CoPilot experiences for developers. This means that Microsoft Fabric will have a built-in integration with Azure OpenAI. We will bring developers in Microsoft Fabric a large set of productivity boosting experiences. Specifically for notebook users, this means that we will offer you built-in CoPilot experiences for generating code, explaining code, troubleshooting, migrating code, and much more. Through an integration with the best-of-breed foundation models from Azure OpenAI, we're contextualizing interactions to be relevant for your data, in your data frames, in your lakehouses or warehouses. But we also want to empower Microsoft Fabric users to create your own AI plugins for answering questions about your data. These items will support security permissions, governance policies, sensitivity labeling, and allow tracking of lineage. These DataCentric AI plugins can be published and used in other chatbots like M365 Business Chat, and can also be consumed in experiences all across Microsoft Fabric. We can't wait to release these features to help all our users achieve more. I hope this session provided you with a good understanding of what is possible with data science in Microsoft Fabric and what's coming. I appreciate your time and want to thank you for listening to this session. Please try out the data science experiences in Microsoft Fabric and let us know what you think and what you would like to see. And stay tuned for many future updates.